Hey everyone, this is an instructional video for IS-201. The point of this video is to give you an idea of why relational databases or relational database management systems are necessary and the good that they can do. So to help you sort of see for yourself why we use these and how we use them, let's start with a bad example of how we store data. I'm in Excel right now, and I want to create a spreadsheet to store and keep track of orders that people place with our company. Let's say that we're a bike shop. Or actually, let's use the sporting goods store example instead. So what I've got here is the beginnings of what I need to keep track of. I've got the customer's first name, last name, and their account number. So let's say our first customer comes in to buy a football. All right. We're going to give him account number 1, and he wants to place an order. Oops. All right, so where are we going to keep track of the order? Well, let's say we put it all in the same table. So order number right here, order date, total. All right, space these out a bit. This is the first order of the day or of our business's life. This happens on 1/1/2014, and he spent $50. Okay, actually in that order he bought 2 footballs and 1 baseball. So where are we going to keep track of that? Well, all right, let's say we keep track of it all in the same table. So let's have we'll call it line item to refer to a particular item on a receipt. Then we're going to need to keep track of the quantity of that item. So now we have football, and I said he bought 2 of those for $50. I guess that's unrealistic. Let's call that 1. And now we've got to keep track of the baseball he bought, or the 2 baseballs. So where are we going to keep track of that? Well, make another entry right here. Account 1, order 1, same date. The total for this order is still $50. Oops. Okay. Baseball, quantity 2. Well, we're not keeping track of how much each individual football and baseball was, so let's add that right here. Price. Okay, the football was $30. Baseballs are $10 each. All right, does this add up? 2 baseballs, $20. Football, $30, gives us an order total of $50. Notice how we have to have 2 rows or 2 records. So let's make sure you understand some key terms. In a database table, each of these column names up here are referred to as fields. These are our database fields. I'm going to center those. And then each field, which is represented by a column, is going to have multiple records in the field. Each row is a record. So, to keep track of everything purchased on this first order at our store, notice how we have to have 2 rows, and we've repeated the name, the date, the total. However, we represent each line item once, quantity, price. So we have a little bit of data redundancy. Data redundancy in a database is bad. It's something we try to avoid. So one of the problems of having redundant data is that it's possible that when someone enters in a new order, they accidentally call Homer's Simpson. Even though this is the same person, now we have inaccuracies in the data or inconsistencies for the same customer. So that's one of the main reasons we want to get rid of data redundancy. The other big reason is that databases get huge. Think of the millions and millions of transactions Walmart processes every single day. Their databases get gigantic, and the problem with that is it's very costly and it slows down processing. And if you slow down the database processing, that means at the checkout line, when people cashiers are checking out customers, that means their systems slow down, the lines slow down, and the company makes less money. So it's critical that companies are able to keep their databases as small and compact as possible and efficient. So we're going to talk about how to get rid of this data redundancy. First, let's add on a few more records just to fill out the data a bit. Let's say Marge later comes in. Her account is number 2. She places an order the following day for a total of $100. She buys a nice leather basketball and 2 footballs. Okay, so the basketballs are 40. I'm going to copy it. Let's see if I can do all that. Okay, account 2, order 1. Just in case you're wondering what these keyboard shortcuts are, if you hold down Control and then move the arrow back and forth, it'll move your cursor to the end of whatever data set you're currently on in any direction. If you hold down Control and Shift, it'll actually select it all. So what I did was Control C to copy, and then I moved my cursor to the place I want to paste, and Control V to paste. Anyway, let's say now that she also included baseball. We know those are $10. Whoops. Sorry about that. Okay, come on, little computer. $10 for a baseball. And she got a football as well. So that gave us 100. Whoops. Wrong one. That gives us 70, 80. So let's say that she actually purchased 3 baseballs. Okay, that gives us $100. Okay, if I double click right here, it'll automatically resize the column to fit the cell. In fact, I can select all of them at once, double click on this line, and it'll resize all of them to fit the data inside the cells. Okay, so here's our table. I think this will do for our example for now. So we want to get rid of the redundancy. Notice now, besides the customer name, we also have line items that are redundant. The same product, we have its name being repeated multiple times. So here's another important thing to keep in mind when it comes to database size. Different field data types take up different amounts of space. So if I have a column that's numeric, like order number, or sorry, account number, order number, or even total, numbers take up far less space in a database than text. Football, basketball, baseball. So text takes up far more room even if it uses the same number of characters. If I just shorten this to a BA, BA takes up far more space than a 50 that's numeric. And we can learn more about why that is in class. Anyway, so let's fix this table now and make it multiple tables instead of one single table and separate the data so that we can eliminate redundancies. So what I want to do is create a customers table for the customer data. I'll start that one. Actually, I'll do it down here. So I'll have F name, L name, and account number. And then over here, let's see, we'll call this the customers table. Let's give it a border. Take outside border, there we go. All borders on that one. Okay, one more time. Okay, and I'm going to put each of our customers in here. More Simpson, account number 1. Marge Simpson, account number 2. Each customer is represented one time and only one time. Okay, now let's come over here and create a different table. Let's make this the orders table. So characteristics of an order, we're going to have an order number, order date, and a total. Actually, I'm going to move these a bit so that we're not dealing with those same column widths. Let's put these over here. Okay. Add our borders, all borders. Looks like we have a total of 2 orders in here, so I'm going to make this 2 rows long. Okay, then lastly, we need some way to keep track of each individual line item on an order. So I'm going to do that right. Let's call this line ID, and I'll tell you why we'll need that in a minute. That's a new field that's not in this table over here. Line item right here, quantity and price. Okay, let's give those all borders. I see a total of 1, 2, 3, 4, 5 line items that are unique across each order and each customer. So I need to make room for 5 records here in my table. Okay, let's add this data in. We've got order 1, order 2. One happened on the 1st. One happened on the 2nd. And this one has a total of $50. This one has a total of $100. Really, it doesn't matter that I'm including or leaving off the $sign. That's irrelevant for now, so don't worry about that. So down here under line items, let's add these in. And I'm going to have to add what's called a primary key. You may have already covered this in class, but if not, a primary key is a column or a field that uniquely identifies every row or record in that table. So imagine if you're looking up a customer account, primary key is something that would be unique to every customer, like their email address, their possibly their cell phone number. When you go to return an item in the store and they're trying to look up the item on your account, notice how they'll ask you for something like that that can uniquely identify you. Sometimes it's just an arbitrary number, like account number. Your social security number is an arbitrary, unique identifier that's assigned to you by the government to uniquely identify each citizen. So if you don't have a natural primary key, and there's a term for that in your reading, you can create one like account number, and that's what I've done down here with line item, or line ID, excuse me. So over in the orders table, notice the primary key is what? It's order number. So order number will uniquely identify every row put in that table. Every time a new order is placed, it'll just be assigned the next number in the list, 3, 4, 5. So anyway, let's place, let's put football, let's put the line items in here. Actually, a better way to do this would be to create a 4th table so that we, well, one step at a time. Let's start with this one. We have football, and actually just notice I'm missing, well, no, I'll come back to that too. Homer purchased a football, 1 at a price of $30. Okay. Purchased a baseball, 2, $10 each. Basketball for Marge, 1, $40. 3. Okay. So we need some way now, let's assume that these are 3 separate tables we're keeping track of. We need some way to tie the data from one table into another. And that's what the primary key, foreign key relationship is all about. So you know what a primary key is now. It's a value or a column that uniquely identifies every record. A foreign key is a way to tie a record in this table to a record in another table. So we're going to need to add in a few foreign keys so that we can tie these rows together. Notice, imagine covering up this table and that table. Imagine it doesn't exist. If we just look at the orders table, how do you know who order 1 belongs to? How do you know who order 2 belongs to? You don't, because there's no primary key, foreign key relationship. So what we do, let me explain what that means. We're going to add a 4th column over here called account number. This is going to tell us, whoops, accountee number. This is going to tell us which customer placed which order. So I'm going to add this into my table. Nope orders. Let's fix this now. Add all borders and then add, whoops, outside borders. There we go. So now order 1 we say came from account number 1. So now we know that this row or this record came from Homer Simpson. And order 2, it's just chance that the order number happens to be the same as the account number. It's important to note that this 2 isn't 2 because this is 2 over here. It's 2 because this order was placed by Marge Simpson, who has account number 2. So over here in this table, this is the primary key. But when we copy this field over into this table, it becomes the foreign key. So this is what we call the primary key foreign key relationship. And when we separate data into multiple tables, you have to have the primary key from one table pulled into another table as the foreign key so that you can have a relationship between the two. So now notice, how many times is Homer Simpson or Marge Simpson repeated in this database over here? just once each, unlike over here where we've repeated their names multiple times and wasted space. So, and by space, I don't mean the geographical space taken up by these three tables together. I mean the total amount of text or integers or numbers taken up inside of each of the tables. All right, so now we have this table tied to the orders table. Now we need to tie the line items table to the orders table. So we need to know which of each of these items occurred on order number 1. Okay, so we're going to do that the same way. We're going to take the primary key from one table and move it into the other table. So here's my question for you. I'm going to pause it if you want to think through this for a second. Do we take the primary key order number and add it as a foreign key into the line items table? Or do we take the primary key line item and make it a foreign key in the orders table? So you may need to actually try this out. If you're not sure, try taking, for example, line item 1 over here, the primary key, and making it a foreign key over here. So let's say we make this line ID, we put number 1 right there. So this says row number 1, or record 1 over in this table belongs to order 1. Well, that's true, but so does record 2. So where do we put record 2? We can't put it down here, otherwise it'll assign it to order number 2 because it's on the same row as order 2. Remember, a record is every value that occurs together on the same row. So, alright, let's say that won't work clearly. Let's delete that over here. Oops. Let's say we add it over here. Okay, here's something to remember. We can't or we don't want to ever make new columns or fields during runtime, meaning when someone goes to the checkout stand and adds a bunch of line items to their receipt or they're checked out, we don't want to have to add a new column for every line item on that receipt. Adding columns is difficult to do in runtime. Databases are set up for rows to be added during runtime. So what we need is to set up the primary key foreign key so that new rows are added for each line item on a receipt, not new columns. Because, for example, if we did add new columns for each line item on a receipt, let's say we're going to call this line 1 ID, line 2 ID, to distinguish between these two numbers and where they appear on the receipt. And then let's say order 2 comes along. Well, line ID 3 it would go here, 4 would go here, and 5 would go here. And we'd have to make a new one called line 3 ID. Okay, now what's the problem if we try and do it this way? Well, now we've got a blank spot here that takes up room in our database with nothing in it. It's a waste of space. So not every order is going to have the same number of line items in it. So hopefully that helps explain why you can't add columns as a foreign key to relate these two tables. So if you're not sure which primary key to pull out of a table and move into the other, try putting it on paper or in Excel like this and think, okay, where would the primary key have to go? And if you start having to create columns, you know you're going the wrong direction. So let's delete all this. All right, let's do it the other way around. Let's take the primary key from order and place it here in the line items table. So for this first line item, which order did it appear on? It appears on order 1. Okay. This line item, which order does it appear on? It appears on also order 1. How about line item 3? Well, that's in order 2, and same with the next two. Okay, you see how now we're adding data down a row or down records. So if Marge were to add something else to her receipt, let's say she also got a softball, got 10 of them at $1 a piece. Now we can say that appears on order 2, and we're just adding rows. Notice that no matter how many items are on order 1 or how many items are on order 2, we're not wasting any space, because every time we add a record or add data, it's added to the rows, and we simply place the quantity, price, line item ID. No wasted space anywhere. So I'm going to undo this one. Let's fix this table now. Actually, let's call that first. Order number. Notice this isn't a requirement, but it's good practice to make the foreign key field the same name as the primary key field it was taken from. However, that's not a technical requirement from the database, and you'll learn why later. So let's fix that. All borders, take border box. There we go. Okay, let's delete that out of the way. Now we have our table set up. There's a little more we can do to reduce and eliminate data redundancy. Pause for a second, think, where are we repeating data in these three tables that we don't have to repeat data? It's not a huge problem to repeat dates or numeric data. Typically, that's the type of data we want to repeat because, like I mentioned earlier, numeric data is stored differently in a database. It takes up much less room than text. What we do have repeated down here are the words baseball and football, and their prices are repeated, which I told you isn't a huge problem, but we can actually eliminate that too. Here's how we do that. Let's break this table into two tables with another primary key foreign key relationship. Let's make, and I should be labeling these here for you. We're going to call this the customers table. Let's move all these down actually to give ourselves a bit more room. I'm going to merge and center that. This is our orders table. Let's move this down. This is currently our, often we'll call this our order line items table. Oops. Okay. Go ahead and bold those for consistency. So what I want to do now is break order line items into another table, or into two tables. So now I'm going to make over here a products table. I'm going to start with product ID, product name, and price. Those are the fields that only need to be listed once. Name and price. Over here it's called line item. I'm changing that field name over here to name. So we've only got 3 total products listed over there. So I'm going to make 3 rows. Whoops. Add my borders. Add my outside border. Okay, we have a football, which we'll call product 1. And clearly that one is $30. We have baseball that are $10. And basket, which is $40. Now we can eliminate the price and the line item fields from over on this side and instead add a foreign key. So I'm going to eliminate, clicking and dragging. Yep, replace it. And I also want to replace price. Okay. Expand that a bit. Now, let's ask this question again. If I want to relate these two tables, obviously product ID is my primary key. But I want to take the primary key from order line items and move it over here into products. Or do I want to take, let's add this products table. Okay, or do I want to take the primary key from the products table and put it over here in line items? Okay, so let's say I still have no idea. Let's just try it out. Let's take line ID and put it over here as a foreign key. Okay, line ID. Okay, football, that is line 1. That's correct. So let's put a 1 there. Basketball, wait a minute, football, didn't that also appear down here as the last item? So line item ID 5 also appears, is also a football. So if I want to keep that on the football row, that means I've got to have line ID 2 out here. And now I'm creating columns because football appears multiple times in this table. In order to tie it to the football line over here, the football record, I'm going to have to put it across columns, and I know that's not right. So let's take that off. Okay. Instead, let's put product ID over here as a foreign key. Notice now I can't have two foreign keys in a table. Now, let's go ahead and put this, the first product, this was a football, that's product number 1. Number 5 was also football. Number 2 was a baseball, so that's 2. Number 3 was a basketball, so that's number 3. 4 was a baseball, number 2. Okay, let's fix our borders. Borders, thick outside border, okay. So now we have order line items with 2 foreign keys, orders with a foreign key, and neither customers nor products have a foreign key. They both just have a primary key. So just make sure you understand that every table, no matter what, will have a primary key, but only some tables will have foreign keys in them to tie them to other tables. So, well, are there some rules we can learn for where we put foreign keys? Yes. That's what ERD, or entity relationship diagrams, are all about. And you'll learn about those in class in the next period, or the next class session. So let's ask ourselves some questions here and make sure we can answer it from our tables. So how many total footballs were purchased? Okay, well, here's what we do. We find football, then we find the number of times that football's product ID appears in the order line items table, and then multiply that by the quantity purchased. So product ID number 1 appears once here with the quantity of 1, once here with the quantity of 1, so 2 footballs purchased. All right, maybe it would help actually if we differentiated some of these identifiers. It wasn't so hard to understand. Actually, let's call this 102 and 103 and 101. So what I'm doing here is I'm going to make this 101, 102, 103, 102, 101. I don't want you guys to confuse this number with the line ID number or the order ID number. So let's call order ID, let's call this 401, 402. Now we have order IDs down here, 401, 401, whoops, excuse me, 401, 401, 42, 42, 42. Okay, and then lastly, let's see, account number, let's call this 1001, 1002, 1001, 1002. Okay, so for those who are still a little bit confused, all I'm doing here is making sure that our primary keys in the various tables don't happen to be the same by chance. I want you to just be able to easily, quickly see, okay, this account number here matches up with this account number over here. This order number right here matches up with these order numbers down here, and so forth. So now let's ask another question. How much total how many baseballs did Homer Simpson purchase? Okay, so we find Homer Simpson. Look at his account number matched up into the orders table. Here's the orders table. Here's his purchase. Okay, then we find the order number and match that up in the order line items table. It's these 2 records. And then how many of those 2 records were baseballs? Just this one right here, and there's a quantity of 2. Therefore, Homer Simpson purchased 2 baseballs. So what we've done here, basically we could answer those same questions with this table over here, but now we have no more redundant data. Each customer is listed once, each order is listed once, each product is listed once. The only place we have repeat is here in the order line items table, and the only thing we're repeating is numeric data, which takes up very little space. This is the idea of a relational database. So let's show you now how all of this works inside of Microsoft Access. I'm going to pause the video now, or stop this video, and then you'll move on to video 2, the introduction to Access, to see how this example continues.